Helicopter 10-2 Advanced Flight Maneuvers. In situations where high density altitude, a high gross weight, or a combination of both renders a normal or steep approach unfeasible due to insufficient power to hover, a shallow approach and running landing is employed. This technique utilizes translational lift until surface contact is made, and for wheeled helicopters, a roll-on landing can be utilized to minimize downwash effects. The glide angle for a shallow approach is approximately 3 degrees to 5 degrees, akin to the angle used in an instrument landing system or ILS approach. The landing area should be smooth, and the landing gear must be aligned with the direction of travel to prevent dynamic rollover. Initiating a shallow approach mirrors a normal approach, with the distinction of maintaining a shallower angle of descent. The power reduction for the desired angle of descent is less than that for a normal approach. As the collective is lowered, heading is maintained with proper anti-torque pedal pressure, and RPM is controlled with the throttle. Approach airspeed is sustained until the apparent rate of closure suggests an increase, at which point the helicopter is slowed with aft cyclic. In this maneuver, the collective primarily controls the angle and rate of descent, while the cyclic primarily influences ground speed. Coordination of all controls is essential. The helicopter should approach the touchdown point at or slightly above effective translational lift, coordinating the deceleration smoothly to maintain enough lift and prevent abrupt settling. Just before touchdown, the helicopter is leveled with the cyclic, and heading is maintained with anti-torque pedals. The helicopter gently descends to the surface in a straight and level attitude, cushioning the landing with the collective. After surface contact, the cyclic is moved slightly forward to ensure clearance between the tail boom and the rotor disc, with the cyclic used to maintain the surface track. It's important to note that if the landing is on a rough or irregular surface, lowering the collective or an abrupt stop may cause the helicopter to pitch forward. Care should be taken not to correct this movement with aft cyclic, which could result in rotor contact with the tail boom. During the landing, normal RPM is maintained with the throttle, and directional control is managed with anti-torque pedals. For wheeled helicopters, the same technique is applied, and after landing, the collective is lowered, controls are neutralized, and brakes are applied as needed to slow the helicopter. Aft cyclic should not be used when bringing the helicopter to a stop. Common errors: adopting overly nose-high stance, inadequate collective throttle use, heading neglect, improper anti-torque pedal input, ineffective translational lift speed, excessive ground speed on touchdown, incorrect touchdown attitude, RPM inconsistency, and misalignment with travel direction, risking poor landings and control issues. Before conducting slope operations, it is crucial to be well acquainted with the characteristics of dynamic rollover and mast bumping helicopter emergencies and hazards. The approach to a slope is similar to any other landing area, taking into account wind, barriers, and forced landing sites due to potential engine failure. Anticipate turbulence and downdrafts since the slope may obstruct wind passage. For slope landings, a helicopter usually lands across the slope to avoid facing downhill and the risk of striking the tail rotor on the surface. The approach involves moving the helicopter toward the slope, being cautious not to turn the tail upslope. A stabilized hover is established, headed into the wind over the intended landing spot. The helicopter descends with the upslope skid touching the ground first. Lateral cyclic is applied in the direction of the slope to maintain the skid against it, while the downslope skid is lowered with the collective. The helicopter remains in a fixed position, and the slope must be shallow enough to allow this. Maximum recommended slope for training is 5 degrees, but adherence to the helicopter's limitations is crucial. During the descent, vigilance for abnormal vibration or mast bumping is necessary. If limits are reached before firmly landing, return to a hover and select a less steep area. After touchdown, reduce the collective, neutralize the cyclic and pedals, and maintain normal RPM until the helicopter's full weight is on the landing gear. Anti-torque pedals are used for heading control, and cyclic is checked before reducing RPM. Common errors include neglecting wind effects, failing to maintain proper RPM, not maintaining heading, turning the tail into the slope, lowering the downslope skid too rapidly, and applying excessive cyclic, causing mast bumping. Slope takeoff is the reverse of a slope landing, considering slope conditions, turbulence, and obstacles. The takeoff involves increasing RPM with the collective down, moving the cyclic toward the slope, and holding it in that direction. The downslope skid rises as the collective is slowly raised, maintaining a level attitude with anti-torque pedal and throttle control. Once level, pause to verify correct settings, then gradually raise the collective to complete liftoff. Avoid turning the helicopter tail upslope to prevent tail rotor contact. Common errors during slope takeoff include failing to adjust cyclic to prevent sliding, not maintaining proper RPM, holding excessive cyclic, failing to maintain heading, and turning the tail into the slope. Confined area operations present unique challenges for helicopter pilots, requiring additional responsibilities as surveyor, engineer, and manager when selecting operational areas. Unlike airplane pilots who operate from known pre-surveyed landing areas, helicopter pilots often venture into uncharted territories. Considerations include selecting landing areas, maintaining rotor clearance from obstacles, and addressing challenges specific to confined areas, such as wires and turbulence. To maximize airspeed with minimum ground speed, takeoffs and landings in confined areas are generally made into the wind. The pilot should start with an accurate altimeter setting to determine altitude. Essential factors during confined area operations include maintaining rotor clearance, especially with the tail rotor, and being vigilant about difficult-to-see wires. If wind is present, turbulence should be expected. For approach planning, conduct a high reconnaissance, considering wind, speed advantage, and forced landing areas. The pilot must formulate a takeoff plan during the reconnaissance, determining obstacle heights and ensuring sufficient power for departure. Takeoffs require a consideration of wind conditions, available area, and potential obstacles. Hovering forward or sideward flight to the takeoff position may be necessary, with attention to the direction of the wind and potential obstructions. Common errors in confined area operations include neglecting reconnaissance, improper approach angles, failure to maintain proper RPM, overlooking emergency landing areas, not selecting a specific landing spot, neglecting wind and turbulence considerations, and improper takeoff and climb techniques for existing conditions. Safe clearance distance from obstructions must always be maintained. Pinnacle and ridgeline operations pose significant challenges due to steep terrain and potential hazards like updrafts, downdrafts, and turbulence. The absence of obstacles doesn't necessarily reduce the difficulty of these operations. Approaches and landings require careful consideration of wind conditions, terrain features, and load. Climbing to a pinnacle or ridgeline is preferably done on the upwind side to take advantage of updrafts. During approach and landing, maintaining a parallel flight path to the ridgeline, staying into the wind, and adjusting the approach angle based on wind conditions are crucial. Ground speed judgment can be challenging, and pilots must perceive the apparent rate of closure accurately. Crosswinds should be managed to avoid downdrafts on the leeward side, and, if necessary, a coordinated turn into the wind may be employed. On landing, taking advantage of the long axis when wind conditions permit is recommended. Tail rotor clearance is crucial, especially in man-made areas. A stability check before reducing RPM ensures safe landing gear support. Takeoffs from pinnacles are considered airspeed over altitude maneuvers. Gaining airspeed is prioritized over altitude, contributing to a rapid departure from unfavorable terrain. Maintaining altitude and accelerating to normal climb airspeed on takeoff is essential. Common errors: inadequate reconnaissance, approach angles, RPM control, emergency landing consideration, wind awareness, elevation sustainment, slow approach, and delayed climb speed, risking safety during pinnacle and ridgeline operations. The summary emphasizes the importance of understanding advanced flight maneuvers, helicopter performance requirements, environmental factors, and safety considerations.